はい、皆様おはようございます。本日はですね、朝からウルフラムリサーチのウェビナー、チャット GPT とウルフラム2つの AI のお話に、お越しいただきましてありがとうございます。ですね、私はウルフラムリサーチの丸山と申します。よろしくお願いします。で、ですね、早速なんですけれども、このウェビナーのシステム、でですね、皆さんの画面の右側に、もしかすると、システムによるんですけれども、環境によるんですけれども、右側の上か下かにチャットというような表示があるかと思います。で、そちらをクリックすると、こちらからお送りするお知らせであるとか、お知らせですね、が見られるようになりますので、そちらを参照してください。で、そのチャットの画面の一番上の方に、薄いピンク色でですね、資料をここからダウンロードするという表示があると思います。そこをクリックすると、今回使用している、このトークの中で使用している資料ですね、ノートブックを、マスマティカのノートブックをダウンロードすることができます。で、ご質問がですね、もしある方は、その画面、その右側のウィンドウというかペインのですね、Q&A というボタンがあると思うんですね。で、これも環境によるんですけれども、もしかすると Google の Chrome ですかね。Chrome じゃなくても出るのかな。あの、このページを日本語で表示みたいな、ちょっと薄いバナーが上の方に出てる場合はですね、それを×印を押して消してください。そうすると、チャットのチャ2までですかね。と Q&A とか、これ世論調査ってありますけれども、これ要はあれです。サーベイです。直訳して変な日本語がこれ多いシステムなんですが、そういう表示が見えるかと思います。で、その Q&A のところから、Q&A をクリックすると一番下ですね、今度は。また入力するスロットがありますので、そちらにご質問を入れてください。そうすると我々に送られます。ですね、そんなところですかね。それとですね、ちょっとですね、世論調査じゃないですけれども、サーベイですね。ちょっと簡単なものを試しで、まずお願いしたいと思います。今回のウェビナーに参加した理由をお聞かせくださいということなんですけれども、あの、選択肢が5つほど出てきています。これ、複数選択ですので、これもそうだなみたいのがある場合にはですね、じゃんじゃん押しちゃってください。はい。チャット GPT なり、生成 AI なり、いろいろ今、話題にはなってますので、いろんな面でですね、単なる、なんていうかな、漠然とした興味から、実際にですね、業務にすぐに活用したいというような方までいらっしゃるかと思うんですけれども、あの、その辺ですね。今回は、あとはウルフラム社としてのお話ですので、ウルフラムアルファご存知の方も多いかと思いますが、その辺との兼ね合いも、あの、まあ、ビウェビナーの中でご覧いただければと思います。はい、よろしいですかね。これですね、じゃあ、あと5秒で閉じますね。結果はですね、皆さんも見ることができて、ですね、閉まっているっていうのが出るかと思うんですけれども、出るかな答えると出るかと思うんですけれども、そちらに投票結果が出ます。はい。こんな感じですかね。ウルフラムの機能の連携に興味があったとか、生成 AI 全般に興味があるといった回答が多いかなという感じですね。はい。でですね、 はい。そうしたらもう、言っちゃいましょうか。あの、ですね、今回はですね、チャット GPT、生成 AI の話なので、なんていうかな、メインというか、主なので、ちょっと我々のですね、専門ともちょっと、我々というか日本のスタッフですね、ともちょっと合わないというか、ちょっとカバーしきれていない部分もあるんですけれども、ちょっと残念なのは、その本社スタッフとの調整がつかなくて、今回は同席しているものがいません。なので、いただいた質問はですね、全部おこ専門的なものにはお答えできない可能性もありますので、そういった場合はですね、後日調べて回答を差し上げるという形を取りたいと思います。はい。で、今回のこのウェビナーなんですけれども、これはですね、先日、実は英語で行われたものに日本語字幕をつけたものです。で、約1時間本体がありまして、その後に質疑のセッションがあります。英語の質疑のセッションがあって、それも残してあります。ただ、その先日、行われたですね、英語のウェビナーではすごく質疑のセッション長かったので、それ一部は、編集して、ちょっと冗長だなと思うところは、カットしてあります。それでも結構残してありますが、面白いなと思うところは残してあります。で、あとですね、マセマティカなりウルフラム言語に関しては、最新版のですね、バージョン13.3というもののリリースと、ちょうどこのウェビナーの時期が、重なっていて、まだギリギリリリース直前だったのかなといったことで、最新のドキュメントがまだですね、13.3、バージョン13.3のドキュメント、マニュアルですね、が公開されてないような意味の発言がありますけれども、これはですね、すでに公開されてます。はい。なので、そこは、ここの中で新しく出てくる新しい関数、ファンクションとして紹介されているものはすでにドキュメントとして、ウェブでもご覧いただけますので、そう思ってください。といったところですね。はい。結構ですね、本人が早口なので、字幕も早いです。なので、ちょっと、そこは、ご容赦くださいというか、心してご覧ください。はい。では、始めますね。
So, obviously, the world has changed quite a bit in the last 6 months. We've been following the development of large language models for a while, but they've surprised even us with the level and rate at which they've developed in the last year. So, what I wanted to do with this webinar is to walk through our perspective on what they bring to the world and how they fit in with the Wolfram worldview that we've been developing for quite a long time now. Now, ultimately, this isn't really a comparison between ChatGPT and Wolfram or Wolfram Alpha as built. It's really a discussion of statistical AI approaches versus symbolic AI approaches. So, from that perspective, what the ChatGPT and the other large language models are statistical AI. Their job is, and I'm going to de-hype this somewhat because I'm no believer in we're on the verge of general artificial intelligence or the destruction of the world, because what large language models do is statistically predict words. Their job is simply to say what word comes next or what sequence of words comes next in a sequence of words. And what makes them exciting is that they've managed to do this. The statistical patterns they've developed have been very profound at capturing the essence of long and short-term structures in text and knowledge. So, as well as knowing that it's about time for a verb in a sentence, they know how to relate the last sentence of a story to the first sentence of a story. They're building up those kinds of patterns. So, this prediction of words actually turns out to be capable of predicting the words that answer a question, or predicting the explanation that follows a statement, or other kinds of things that have very human appearance of intelligence, such as responses that seem to obey instructions. But fundamentally, what they're doing is guessing probabilistically what words come next. And in fact, by their very design, they do that with a certain amount of randomness thrown in, because it turns out they don't look nearly as human if they simply give the most likely next word. They always try and give something out of one of the several likely words that comes next, which makes them much more surprising and relatable, but also makes them fundamentally unpredictable. Now, on the other hand, Wolfram has always, for the last 35 years, been building out the symbolic AI world. And I'm going to define that as taking structured information, such as images or algebraic maths or documents, and operating on those with very defined rules of behavior. So while some algorithms are non-deterministic or are seeded randomly, fundamentally, we're trying to produce reproducible steps pretty much for all of the computations that we do. Well, I'm sure most of you in this webinar have some sense of what that means in practice, what we've been building at Wolfram Research for the last 35 years. But just to give you a sense of what that is, we call it computation, and it's pulling together all of the world's algorithms from all kinds of different areas of computation. So that includes algorithms that have enabled things like large language models, all kinds of statistics and machine learning and neural network algorithms, sort of classical statistics, but all kinds of areas of computation that aren't sort of pure data science, like geocomputation or network analysis or seasonally adjusted forecasts on time series and things like geometry and optimization and all kinds of different data like audio and video and text analysis. And a lot of it is very domain specific. So we've built out algorithms for all kinds of science and from sort of traditionally computable subjects like physics and maths, but also algorithms from more recently computable subjects like biology and so on, and across engineering fields and all kinds of modeling on top of that. So this is a big lexicon, but they all basically follow this idea that there are prescribed algorithms that understand specific pieces of behavior, which we then assemble to try and apply to the real world. Now, at this point, those of you who know a bit about this might think, but hang on a moment, you've got Wolfram Alpha. That's different, isn't it? Wolfram Alpha takes natural language and produces answers. Isn't that exactly what ChatGPT is trying to do? Well, on the surface, superficially, they look pretty similar. You type a question in, you get an answer out. But if you peel back the surface of Wolfram Alpha, the way that we've gone about it is fundamentally different to the large language model approach, because as fast as possible in the Wolfram Alpha world, we dispense with a natural language. So we have a generalized grammar rules that deconstructs the sentences and tries to turn it into a symbolic representation of a question, usually something of the form of what is the property of this entity, or what is the value of this piece of data pushed through this algorithm, something very precise and symbolic. And then once we've reached this point, we're in this computation world, this symbolic AI world. So we've got collections of algorithms that know what to do with different kinds of data, real-time data feeds, and built-in sources of knowledge. We do computation, and then we use a templating system to put the computation into the framing of some words to give it sentences. So none of the processing in the middle in the Wolfram Alpha world is done in kind of language that's stripped away as early as possible and then re-injected at the very end. So given that we have things like Wolfram Alpha, it might be reasonable to ask, is this some kind of existential risk to Wolfram Alpha that large language models seem to have come along and done an excellent job at the thing that we've been building? And at first, we were concerned about those kinds of things as well, until we kind of started analyzing the strengths and weaknesses. And it turns out that if you break it down, the strengths and weaknesses of the large language model approach and the computation approach are almost diametrically opposite. They're very complementary technology. So on the computation side, we're very good at the logical thinking, following rules, working with big data, reliability. On the large language model side, they're very good at wide range of inputs, human-like interaction, and undefined fields and unstructured data. And to make that better, I'm just going to go through those one at a time and show you what I mean by and why I've sort of ticked and crossed the boxes on that. So here's a kind of computational thinking type thing, the kind of thing that there are examples of large language models doing really interesting, having really interesting capabilities here. but fundamentally, they're not very good at it. So those are the outliers where they really seem to be able to assemble logical thought. Actually, it very quickly breaks down. All my examples here are ChatGPT 3.5, but while GPT-4 has improved on that, they're still fundamental to the approach of LLMs. So here I've asked this sort of simple logic problem. Alice is older than Bob, Bob's older than Charlie, Charlie's younger than Derek, and then ask the question, is Alice older than Derek? So the ChatGPT answer comes back with an argument that says, yes, Alice is older than Bob, and here's the explanation of why. But actually, if you stop and think about it carefully, the answer is it's unknown. Now, in the quantifier elimination world of being able to take that as a kind of logically stated set of inequalities and using Wolfram languages for all and reduce functionality, we can conclude that that is not a true statement. And in fact, if we ask it the other way around, we can say, is she in fact younger? We can see that that is also not true, that this is an indeterminate question. We cannot strictly say it either way. And this is quite a simple, 10-word problem. So if you think about the kind of larger scale logic problems where you are working with systems of thousands of equations and thousands of unknowns, that is never going to be within reach of the large language model approach. But actually it goes even deeper than that, because the large language models can't even handle any kind of rules in a kind of safe and systematic way. So something as basic as arithmetic is fundamentally beyond them, that when you ask most arithmetic questions in ChatGPT, it gets them right, because you mostly ask questions involving 2, 3, 4-digit numbers, and it's pretty much seen every combination of adding and subtracting and multiplying those numbers. But as soon as the numbers get a bit more bigger, or the arithmetic gets more complicated, like this, I don't know how many digits I got here, 8, 9-digit numbers, we can see that compared to the correct answer, it's looking plausible because the first 3 digits are correct, but after that, all of the digits are just fiction. And that's just arithmetic. When you go to something more complex, like asking it for some calculus, we get back this plausible-looking answer, and again an explanation of some of the reasoning for why that is and what it means. But if you compare it to the Wolfram answer, they are almost completely different. A lot of the symbols and bits are the same. It's sort of using the right words of maths, but just in the wrong order and in the wrong structure. So there are things they have in common. It seems to recognize there's likely to be a sine 2x going on involved in here, and for some reason it's also agreed on the quarter, but the structure of the thing as a whole is completely different. And again, this is a relatively simple piece of algebraic maths. So really it comes down to that whenever you have things that have precise rules and you have to repeat them or apply combinations of them very quickly, the LLM approach breaks down. And in a way, perhaps that's understandable, since it's trying to produce very kind of human-like behavior, and the approach it's taken is very verbal. We're very bad at doing maths in our heads and spoken out loud. So perhaps it's the same kind of reason why we find maths hard to study, and we spend a long time developing the skills to be able to do this maths ourselves as humans. So another thing I said was a weakness for large language models is big data, which seems surprising because we read that they're trained on terabytes of natural language. The training is on big data, but actually when you use the large language model, they have a kind of working memory known as an attention. And in GPT 3.5 that I was using for this example, that is about 2,000 tokens. For GPT-4, it's about 20,000 tokens. But so I've rather meanly contrived this example where I've given it a list of 2,000 items and said, what's the last item in the list? The kind of the simplest data science question you could ask, what's the last element? And you can see that it fails at that, because the question is falling off out of its memory by the time the last data is arriving. It simply can't hold all of that to be able to process it. And of course, in data science world, 2,000 items is nothing. It's even Excel can handle that quite happily. It's trivial for me to ask the same question with a randomly generated 10 million element list, and instantaneously I can do that accurately. And certainly it's routine in our world to be working with hundreds of megabytes, gigabytes, even larger amounts of data, not 2,000 items. But here's the thing most people are talking about, and it's a fundamental issue, which is reliability. And you'll notice I've used the word plausible actually quite a few times already, because in a way that's its target function, is the LLMs are trying to produce words that seem likely and plausible. Their job is not to be correct or to know the answer to things. That's an emergent behavior that comes as a side effect of trying to sound plausible. But the key thing is plausibility. So here's a typical question I've asked it: provide data on livestock populations in Turkey. And here's the answer that it gave me. And I've highlighted 2 bits of the answer there, that it's claiming there's 33.4 million sheep. And it's given me a citation to try and make it more convincing. Now, ChatGPT has been known to completely invent citations. So I thought, this would be great as an example to show an invented citation. Actually, on this occasion, it's a real citation. Turkstat is a real thing, and it does hold populations of livestock. So it's made a really good match there with suggesting Turkstat. But I took the time to go and trawl through the tree structure of Turkstat to find the relevant page. And here I finally stumbled upon the documents that it's citing, that the 2020 corrected animal populations. And we can see that it's a different number. So in fact, all of the numbers are wrong. They're all in the right ballpark, but they're all different numbers that it's made up that sound roughly right. But to me, even more dangerous than the fact that it can't get the numbers right is that it makes an effort to try and convince me of the correctness. Like the loudmouth man down the pub who claims to be an expert on everything and shares his wisdom, but actually turns out to know nothing. It's saying with confidence to cover up its lack of preciseness. Now, so far I've been very negative about LLMs. They are amazing, and they do some things that are really big improvements. One that's interesting to us, of course, is that they can take a really wide range of inputs. So here's a typical query you could type into Wolfram Alpha, asking for things like the largest country. But I've tried to mangle the question by elaborate use of words, try to use obscure words and not a natural word ordering. And in the GPT world, in the LLM world, it can rephrase that into the short, concise 10-word version and unscramble that complexity. Wolfram Alpha would completely choke on that question in the way that I've phrased it in the input. And so that ability to strip away the confusing paraphernalia of language to convert to the essence actually is a really powerful feature that we want to be able to make wide use of. Of course, the thing that amazes everyone, and there's no denying it, they are great at writing human-like words. So all kinds of fun things they can do, where you could ask it to describe a topic in a style. So here I asked it to explain Wolfram Alpha in language for a 7-year-old, and it's done a pretty good job of that. I've taken a large amount of text and asked it to précis that down to a few words, and it's made a great summary. I can go the opposite direction and say, here's a point I want to make. Write me a paragraph that makes that point well, and it can synthesize the words, it can transform words, it can extract essence, it can write poetry, it can do all kinds of amazing things with words. And really, that is an amazing breakthrough compared to the state of the art for the last 20 or 30 years. Perhaps a little harder to know whether it's useful or not. Large language models do something interesting, at least, with really poorly defined or poorly understood fields. So I don't know why I thought of this, but this was my example. How should I train a dog to sing? I have no idea whether this really would work, but at least it has something to say about it. And in the computation world, I lead a technical services team here in Europe, and we take customer projects. I know if some customer came to me before this technology came along and said, I want you to build an algorithm for training a dog to sing, that's a serious invention task, and I wouldn't know where to start, and I'd want lots of data and feedback, and I don't know where I'd go. It would be a major research undertaking to do that algorithmically, and we got something useful here with zero effort. And the last thing I'm listing is one of their key strengths, and this is an important one, which I'll come back to a little bit later in the presentation, is handling of unstructured data. So I've given it a fairly straightforward thing here, which is a sentence, say, 2 basset hounds were walking down the street and they met a Persian cat talking to a Labrador. And I'm asking how many dogs are mentioned in that text. And, there is a combination of word matching to understand that a Persian cat isn't a dog, that a Labrador and a basset hound are. It's got to have associated the words to and a with the right nouns going on there, and it's got to pull that together to make the number 3. So this is kind of amazing that it can take that and take that unstructured mess of information and extract the key facts that I wanted to get out of it. And really, I think in many ways, this is the more exciting thing than the ability to chat to the computer. That's the thing that everyone's excited about because it's, finally the Star Trek computer. But this is really a profound change to be able to handle unstructured data that is as important as conversation. So that's the pros and cons. We've got these two worlds, and in many ways, it's like the classic, although inaccurate, model of the human brain, that there's a left brain for logical, rational thinking, and the right brain is for poetry and language and emotion. And like any rounded person, we need to bring together the skills from both halves of that capacity. So what we've been thinking about really since shortly before this really made news, when we were first brought on the inside of the announcements that were coming, is how do we pull those two worlds together? And that's where, for those of you who've heard about the announcements that are public so far of the ChatGPT plugin, and we've announced, so we were invited to be one of the first plugins by OpenAI. We've also been invited to be part of the first round of plugins for the Bing version, for the Google Bard version, and we're working with other AI providers to provide plugins that aren't yet public. That's the kind of simplest mechanism for pulling the two together. So let's switch to a browser here for a moment, and let's do this one live if OpenAI on my free account is forgiving enough to give me some CPU time. And we'll ask the question. I've got the Wolfram plugin enabled here at the top. And I'm going to ask the same question that I used as an example before, which was, tell me about livestock populations in Turkey. So ChatGPT is going to start thinking about those words and assembling some sequence of text. But the first thing it's done is recognized that this is something we might have something useful to say. So it's this little used Wolfram pod has come up, and what that was doing is behind the scenes, it's called Wolfram Alpha and said, about livestock population, give me the numbers. The numbers have then come back, and it's used those numbers. It tends not to hallucinate and make things up when you provide it with facts and say, use these numbers, and it's woven them into its answer. And I guess I could go a bit further than that and say, bar chart that. And that would also hopefully recognize that bar charts are something that we know about in the Wolfram world. So again, we get using Wolfram, and it's calling us, and it's hopefully going to get a moment it will say used Wolfram. It's okay. Here's the answer coming back. And so it's taken the data from the first part, carried that forward in the context of the conversation, passed it to us where we produced a bar chart, and we fed back a URL so that this bar chart can be displayed into the chat. And now we're also escaping the world of words because we're generating pictures, even though LLMs, as they stand, are kind of strictly in the world of words. But that's one way round. That's Wolfram as a plugin to ChatGPT. The intelligence that's in charge there is the large language model. It's receiving the question, and it's deciding that we have something useful to contribute, and it's making the decision to call us, and it's making the decision how to use the result that comes back. So the LLM is totally in charge in that conversation. We're just injecting facts back into the conversation in order to avoid the hallucination. We also want to do this the other way around. And so I'm going to show some features here that are coming in the next release of the Wolfram language. And here I'm within the Wolfram language, so I'm in a code world. You would layer a user interface over the top once you've built your application, whether that's through notebooks or websites or hiding it behind an API. But at the code level, I'm setting up an LLM function. So this is a function that's going to be powered by the large language model. And I should point out here, this is LLM function, not ChatGPT function, because we want to be agnostic to the back end. So there are some options to say which backend I want to use. At the moment, we only have OpenAI's backend, but the plan is that will just be a choice to be able to flip that to different, cheaper, more expensive So, for example, choosing between GPT-4 and 3 affects the billing. So we might want to use the lower model unless it's complicated, and then switch to the high one. But what it's doing is it's setting up a function that will be evaluated in the LLM world, which is write a blast summary of a blast share price yesterday, given the following facts. So now I can use that function as if it's a built-in function in the Wolfram language. I can just say, right, I want some text, which is the finance story, and here's the parameters being filled in. If I was doing this right, I would probably have some model for projecting whether I thought the shares were going up or down, and make this positive or negative depending on my model. But here I'm just going to randomly choose between exciting, optimistic, and pessimistic. I threw in the word automatically, and I'm fetching Wolfram Alpha's financial data. So that one of the things that the LLMs don't do in their core technology is they can't do anything with live data, because they're pre-trained on a snapshot of data that is frozen somewhere in the middle of last year when the training runs were done. So we're fetching live data and feeding that into the slots in here. So this will become write an exciting summary of Microsoft share price given the following open, high, low, close numbers. And here's what it came up with when I ran it about an hour ago to when I was testing this, that this machine was good for this talk. So the numbers here all came from us. The narrative was written by large language model, but we were in charge. We demanded from the LLM that we wanted these words rather than it making some decision to call us. Now, the Wolfram plugin is already kind of interesting for filling in a lot of that sort of knowledge and computational gap in the LLM, but it is very generic. One of the things we want to do is to be able to combine your knowledge to make specific plugins that that do more than the kind of generic computation. So once you kind of open up your mind to that idea, that's all kinds of bi-directional things that a plugin that actually had privileged access to your world could do. It could answer questions using your private information from your database. It could action things in the real world in the way that, you know, we use Alexa to control our heating and so on. We can action things in the outside world. As soon as we've got a plugin in the Wolfram language world, everything that we can do with computation becomes available to chat or contrive chat. And what that looks like actually turns out to be really simple, because we've built a lot of the infrastructure for symbolically representing symbolic knowledge. We built infrastructure for deploying things, building automatic APIs for import and export and asynchronous operations. All of these things we've been building for years because we've used it for deploying applications that are built in the Wolfram language into organizations' infrastructure. So this is the plugin command that create a custom ChatGPT plugin, and what it does here is it declares a plugin with a certain name, so we can have more than one of those, but there's one here which is called UK Income Tax Calculator, and it's got more than one or more endpoints. In this case, just one endpoint, which is the tax due endpoint, and then that's the symbolic representation of an API that will serve the parameter income with some calculation. And I picked this example because actually, from the UK tax point of view, it's kind of amusing that a few governments ago, the government wanted to raise income tax, didn't want to admit to it, and so it hid the personal allowance, which is the tax-free bit of your income. They made that go down as your income went up, so they could say the top rate of tax hasn't changed, but they were raising more tax from rich people. And so that really confuses GPT. It can't do these tax calculations because of this bit of the calculation that changes the personal allowance. So having set that up, I've got an API endpoint, and I'm going to walk you through the steps. Actually, I probably already have it installed here, but let's go and do a new chat and go to plugins, and let's uninstall the existing plugin because I've already got this installed here. So I want to do plugins, plugin store, and I'm waiting for it to respond. Installed. Let's uninstall that. I'll see if I can make this a little bit larger once I get that removed. How do I zoom Chrome? Is it? There we go. Right. So what we would do now is we would do in let's just close this out and start again. So I created my Wolfram side of the plugin. I need ChatGPT to know about it. So I go to plugin store, develop your own plugin. I paste in the endpoint. I seem to have copied more than I wanted to there. So let's just only need the URL. Okay, seems to be having trouble deleting in this window. Maybe I would be better to repaste it because the JavaScript is being very slow here in their website. Let's paste that again. Oh, and it didn't copy. Oh. Okay, I'm just going to copy this by hand. So what was it? It was johnm.assets. Assets. wolframcloud.com. And paste. Right, so we're telling it to go to the endpoint, and it finds it. So it says, okay, I recognize that. That looks like a valid ChatGPT plugin. I'll say install that and acknowledge my way through a couple of warnings. And now the plugin has been added to my list. And let's uninstall remove the Wolfram plugin, and let's just leave this new custom one. And if this works, I can now say, what UK tax would I pay on an income of, let's be rich here, of £114,000. So income. So if I've done this right, already from the fact that the plugin has got names like income tax calculator, it's guessed the usefulness of it. If I was doing this properly, I would give it additional information of where you would apply this and what circumstances, what it produces, what it gives out. And I can do all of that through prompt engineering, but it's already guessed what it's for and what the parameters are from the description of the code. And now it's done the same thing. It's called this new plugin, and it's used this, albeit very trivial, custom bit of knowledge that's running now in the Wolfram Cloud that I just created. So in a few seconds, we've got a plugin that has knowledge that is, potentially secret to me. And on the Wolfram Cloud, that could be potentially doing a database connect to my databases and pulling data out that is clearly not available to the wider public. Now, that's one way around. That's the GPT in charge. But we also, just like our plugins, we want to have the opposite way around. And so we have the same business going on within the language. And this is what it looks like from the language point of view. We're using LLM synthesize to say we want to use the LLM infrastructure to answer some question or to write some text. So here's the instruction on what I wanted to do, which is to write a short paragraph comparing Chicago and New York. And if I just did that on its own, it would write me a nice short paragraph, probably about what the nice buildings are. I don't know what it'll come up with, whatever it feels like. But I'm giving it a bit more information. The LLM evaluator is where you tell it which the back end is, whether you're using Bard or GPT, and what model and what the temperature is. But I'm also dropping in this extra piece of information that there is a tool available to it, which is a tool called City Finder Population, which will do the following thing, which has the following parameters and runs the following Wolfram language code. So in the same way that has happened when it said using Wolfram, when I call this LLM synthesize, these words are written by the LLM, but this time under code instruction, but it still made the decision to come back and get these numbers. So rather than injecting the numbers in, saying, I want you to use this number for the population and this number for the population, the way that I did with the finance example, this one is left it up to the LLM to decide, but we're controlling the thing from Wolfram language code. Right. So that's sort of the what we're trying to address with the plugins: arbitrary ways of injecting facts, injecting reliability, making LLMs able to call the computable world, allowing the computable world to fetch narrative when it needs it, and all of that sort of infrastructure that you can build your applications on top of to be able to leverage best of both worlds. But I said one of the things I thought was exciting was unstructured data. So I want to talk about that a little bit. In the end, the infrastructure is exactly the same. We're going to use LLM function and the like to be able to connect to external APIs to call on that world. And when these smaller models that people are developing come on stream and become more reliable, that might be calling an LLM that's running right on my machine in private without having to use external APIs at all. But we're not quite at that stage yet. And I've actually grouped together here not just unstructured data, but unstructured tasks, because I've had a line that I've used for a long time when I talk about machine learning versus classical modeling, which is if you're data rich and understanding poor, then machine learning is the way to go. And if you're the converse holds, though, that if you are understanding rich and data poor, then using the physics or the equations of the system are the much better way to model. I now see a kind of third strand, which is if you don't really know what to do, but you kind of know it when you see it. You can describe it and you can recognize it, but you're not really quite sure how to do it. That's a really good place for these tasks that the LLMs can help with. So let's pick through a few examples here. We'll start with perhaps the kind of low-hanging fruit. One of the easiest things that is obviously useful is data extraction from unstructured data. So it turns out that large language models have an interesting emergent behavior, which is in-context learning. In the classical machine learning world, if you wanted to learn something, you give it thousands and thousands of examples, and you train the weights of the model until it's learned that. And that's how the LLM was created. But LLMs are incredibly expensive. The really big ones like GPT-4 are very expensive to train. A full training run is in the hundreds of thousands of dollars of CPU time, beyond all but the biggest organizations. But it turns out that in the context of the question, you can give it a light training through examples, and it does a reasonably good job of using that in many situations. So we built, as a kind of next level up from the LLM function, a primitive called LLM example function, whose job is to take input and output examples, kind of like Classify does, but using the LLM technology. So it actually seems to extrapolate really well from a small number of examples. So here I've used 3 examples. This is what I think it might see. A piece of text that's talking about some people. And in that example, what I want it to do is to produce a string that is the Wolfram language expression for an association of key value pairs with those values in. So I want it to label, find the word John, which comes from here, and label it with name. And I want to find this 52-year-old bit here and label that with age. But when I do that, I want that to be a Wolfram language unit. So it's going to be a quantity in the quantity of years. And I've got 3 of these examples. This one illustrates what happens if something isn't mentioned. I've got a missing. This one illustrates what happens if you've got 2 people mentioned in the same sentence. And that gives us now this LLM example function. And that's already pretty good at taking similar kinds of text. Not the same, not doesn't have to be one of those exact patterns, but things that are of similar complexity and being able to extract that data. So here I've given it this unseen data here, and I've shaken the sentences up a bit so they're in different orders. And I've tried to separate the height a little bit from the word tall, but it's able to take that sentence and extract it out into a computable data structure with units that are immediately computable. So what have I done here? I've taken the first record here, that age, so the 70-year value, and actually convert that to days because it's in the Wolfram language. It's now immediately computable with all of our computational infrastructure. So this is a really powerful paradigm for setting up functions where you kind of can describe the task just like I would with a junior employee, where I'd sit them down and say, here's the job, you've got to get these values out of this data. Here's a couple of examples. You've got the idea, off you go. But it turns out to be quite flexible in the kinds of things that it can do. So here's a sort of different example. This time we're going to numerical values. I'm building a social media moderator function that wants to detect offensive posts in public. And I just train it with some examples. I show it, this is an example of a 0 offensiveness. And in my scale, the I know where you live and I'm coming to kill you is the most offensive thing on here. I tried to make it presentation friendly because obviously we'd have a whole bunch of other things in that would show up that we want to give examples of. But just from those 10 examples, to give it a sense of this escalating scale of offensiveness, it's able to take some phrase here and say, oh, you've thrown a mild insult in here. That's a 6 on my scale, something equivalent to the you are a moron level of, or somewhere between you're a moron and you're an ugly donkey level of offensiveness. Here's one that's not quite so obviously the same thing. This was a project that I was discussing with a medical chat company who were taking voice over phone transcriptions to be able to make use of the conversation. And the transcriptions go wrong because they're listening phonetically, and while they do error checking, like, is that a real word? And they they fix jumbles of syllables that don't appear to be a word into a word. They don't understand the context of the conversation. So in the same kind of way, in this case, 2 examples, I've shown it examples of how to fix a mistranscription. So I've got this phrase that's in the topic of heart disease, Asian populations might be actually a mistranscription of atrial fibrillation. So they sound vaguely similar, and you can imagine with a poor pronunciation and a phone line that it could mistranscribe that. And already it can do useful things. So here's the unseen data. I'm not even in the context of hearts. I'm just now in a completely different context, but I told him that in the context of eyes, I have cats and a glad aroma, and it says that's probably I have cataracts and glaucoma as correction, which is kind of impressive. In reality, you might give it 30, 40, 50 examples. You've got to allow for the context of your LLM, because you can't give it more than the 2,000 or 20,000 tokens. You can't give it tens of thousands of examples the way you would with training. But this works really well where you're low on data and low on understanding. Should we do another one? Let's do the next one, which is this is kind of a useful one. So things like ontology mapping, it's very good at. So this time I'm not using an example function. I'm using I know what I mean, but I don't know how to do it approach. And I'm creating a function whose job is to convert a drug name to be provided into the purpose of the drug. And this is a bit of prompt engineering because I don't want descriptions or essays about the drug. I just want it to return a single word. This is the kind of instructions you have to give LLMs. And from that, I've got a function that I can now map down a database of drugs in order to put them into categorizations. And you can see here that my list of 3 drugs has 1 analgesic and 2 anticoagulants in it. Now, in the old world, I would end up having to dump out all of the values in one database and in another database and create some kind of mapping between them, and maybe do some kind of nearest spell check correction in case it said aspirins instead of aspirin. And there'd be all kinds of code and data required to be able to execute that. And now I haven't actually analyzed the reliability of this, but at some level it's working in what is 30 seconds worth of coding, which is a real kind of breakthrough in data cleaning, which of course is the expensive part of data science. I'm going to skip these examples as time is getting on, and we will talk about another topic which comes out of this, which is large language models actually are quite good at code. There's a limit because it's a kind of computational thinking. So above a certain size, they break down and start doing the wrong thing. But actually, they do slightly better at code than they do at maths, because code has so many of the features of languages. It has a syntax. It has a kind of repetitive structure to it. In the Wolfram language, you've got open and closed square brackets in the way that in English you have full stops and commas. So it's used to these kinds of structures. And if we jump back to the LLM here, let's have a look at what happened in my Turkey example. Behind the scenes, there's kind of an interesting detail here, that there are 2 ways that the 2 systems have talked to each other. In the first one, it did that kind of question rephrasing that I talked about earlier, where it's, it hasn't had to do much. It's thrown away the words tell me about, but it's turned that into a Wolfram Alpha style natural language query, something we can parse, and it's used English to English as its way of conversing with the external system. In the case of the bar chart, it's conversed using Wolfram language code. So it's actually synthesized the code for a bar chart, including the options and any styling information, and then it's executed that code on our servers, and then we've returned the result of the execution. Now, obviously, there are sandboxing issues. We take care of that in the Wolfram Cloud already. You don't want the LLM to suddenly fantasize that what you really asked for was file delete star dot star recursive, and that it suddenly does some harm. So you have to sandbox the execution. But this ability to write code elevates the ability of the LLM to be able to do computational tasks, because where it would get muddled, it can now synthesize some code that can be executed and compute the value. Now, that actually leads us on to a kind of new paradigm, which is one of our challenges has always been that Wolfram language, of course, is a lower popularity language compared to things like Excel, and Python, and things that people get taught routinely at college or in the workplace. And so one of the barriers has always been, how do we get people through those first few hours, couple of days of learning the Wolfram language so they can be productive? Well, this now bridges that gap. And so, we thought about how to do that. Code assistance tools, that's one way, code checking on errors. So we've been building some of those things in. But one of the paradigms that we've led on for 30 years is the concept of a notebook. And in a way, ChatGPT is like the computational world was back in the 1980s before we invented the computable notebook, which is you did things through the command line, and the stuff that I've done earlier, well, that's gone. I can't go back and edit that. It's just a immutable record of things that I typed, and I have one point of entry, and then it's frozen as it goes up. And we invented the notebook to make computation much more interactive, so you could go back and edit things, you could reevaluate things, and you could explore much more freely. So we've taken that paradigm and brought it to the world of notebooks. So the idea is that I can type in here into the notebook, into this chat thing, something that I would like to achieve in the notebook. So let's make plot the differences between the first 500 primes. Hopefully what will happen now is this will call our preferred LLM, which will synthesize some code for us. And we can go and say, okay, that looks like good code. Let's run that. Okay, that's good. Let's carry the conversation forward. It will remember the context like it does in a chat session. So what would I do with this? Let's do add a moving average with a window of, what is it, 500 points. Let's have a window of 20 points. And you can use that context now to take the code it already wrote and modify that. This is looking like it's done a decent job. And there's our now moving average of the differences and primes, and the patterns start emerging. But this is all modifiable. So I can go back up to the top and say, actually, now that I've got this thing working, what do I do to change this to 1,000 primes? I can reevaluate that, and everything below will use that context when I ask further questions. So it's resynthesized the code. And we think there's all kinds of interesting things that can be done in this in terms of injecting context into the notebook. And perhaps I could show one here. This is hardly a very sophisticated example, but I was playing around with it a minute ago. Why is my mouse gone? Oh, well, I'll open recent. I think I had it on my notebook. Oh, okay, I don't. Let me just maybe if I just open it from the desktop. Oh, no, I've got loads of things on the desktop. This is not going to work well. Yes, here's a chat notebook. Oh, no, that's not. Okay, well, I'm not going to show this. There may be in the questions if people are interested. You can pre-prepare the context. So you can have a notebook that is given a notion of a persona. So you could say this notebook is going to speak to the person like they're a 5-year-old. It's for children. You can pre-decide that we're in the context of say physics, and stick to the conversation in that space. We can prime it with things that it might want to talk to me about, and then the conversation is pre-led. You open the notebook and you type chat, and it'll say, no, we're talking about physics. We're not going to talk about the weather today, and keep you on topic. I put together an example that was for writing lessons plans, and it asks you as its first step, what do you want to plan on? And you say causes of World War II, and then it says, and what age group? And you say 5-year-olds, and then it writes a little lesson plan step by step. And it's been given some prompt engineering to tell it what a lesson plan should look like, so that it can just appear like it knows what I want in the first place. Now, I've been using this phrase prompt engineering throughout, and it's an interesting new paradigm for expressing yourself, because it's linguistic programming. Prompt engineering is all about trying to describe what you want, so that the thing doesn't just write some fantastic essay about the topic and will go off on its own direction. And there are all kinds of lessons being learned about how to construct good prompts. And so we've been thinking a little bit about how to make prompt engineering easier. And our approach to that has been to launch this prompt repository. And I'm on the wrong screen here. So this is the, at the moment, it's mostly fairly empty because we've only just put it up a few days ago. This is a repository where you can get prompts for particular tasks. And you can see here that there are various different categorizations, possibly more to come. There are personas. These are all kind of stylistic things. Some of them, very useful, like speak formally or speak, relaxed, friendly manner, or be a tutor. Those are kind of persona type things that are all about obviously there are some kind of amusing but pointless things in here, like speak like William Shakespeare or speak like a gangster, to give you the idea. But the idea is personas could be really about directing the style of the conversation as well as the choice of words. Then there are functions, which are things that can do useful tasks. And then there are modifiers that can transform things. And the idea is that, like all of our repositories, these are deeply plumbed into the Wolfram language. So here's some examples of what those look like at a code level. At a notebook level, if I go back here and where's my prompt notebook? Actually, let's go back and show you this in the chat notebook before I do these code examples. Let's go to new chat notebook. We have the notion of the persona on the left here. So I've got a few personas installed here. I'm going to use Bernardo, which is one of these whimsical things. What can you help me with? And it will now take on the funky Bernardo persona, which likes to be really cool and ends everything with an emoji and is sarcastic and irreverent. So in the notebook, we have this sort of mechanism for being able to reference these chat prompts and personas within the content. I can do this actually within the context and say something like, what is a black hole? But I'm going to add a modifier to that, which is going to be, and I don't know how to type hash on this keyboard. There we go. Nope. Hash, explain like I'm 5. Now, when I ask this, I'm modifying its natural behavior. It's got the default persona, but I've modified it, say, speak to me like a 5-year-old, and now it's saying it's a really big, super strong vacuum cleaner, and that's its wording for it. So at the code level, we're trying to do the same thing by having these things automatically download and install. So here's a typical LLM synthesize where it gives you a very prosaic answer when I ask it how many legs does a spider have. But if I want to do something computable, I might want to give it the LLM prompt numeric only, which is one of these functional modifiers that says that ensures that what comes back from LLM synthesize is as if possible converted into a number. So now we just get the number back, not a description of the number. Here's a similar one, which is if I want a Boolean answer, I can put in the LLM prompt. I want this to be a strictly yes/no question. Should I eat spiders? And now instead of telling me why that's bad, it just says no. Oh, and here's the explain like I'm 5 example within the code. Some of these things take parameters as well. So the translate prompt can take a second parameter for the language, and now that's a quick way of saying I want to take that last answer, the black hole 5-year-old explanation, and translate it into French, or translate it into formal medical speak, or whatever the modifier is. So like our other repositories, the idea is anyone can contribute to these. I've got a few ideas that I want to add that I haven't got around to yet, and hopefully we'll get away from the kind of amusing whimsical things and build up a greater lexicon of the really useful functional things that can achieve certain tasks, like categorization or mapping of data, and so on. Some of these prompts are very simple. They can be one-liners. Some of them are elaborate, sort of 200 lines of explanation that will only work in GPT-4. So hopefully that gives you a sense of what we've been doing. Here's my kind of left brain, right brain diagram again. But mapping out the two worlds of the probabilistic language approach and our Wolfram Alpha computation approach. But basically the building blocks we're trying to create are all of the connections one way or the other to be able to prime with style, to be able to prime with facts, to be able to query computation, to be able to construct narrative from computer or LLM approach. And what might appear on the surface might end up looking just like Wolfram Alpha, but behind the scenes it's completely different. That you might have chat input and some kind of knowledge-based, computed, useful decision-making report at the end, Or it might be this is just invisible infrastructure, and all you're seeing on the screen is the things that your app is doing, and behind the scenes we're using these kind of LLM engineering to solve the tricky tasks of how do we process the data that informs your app, and you may have no idea that words are ever involved in the process because it's just part of the, it's just another paradigm of computation now from our everything is computation world viewpoint. So thank you very much for listening patiently through that. I see that there are some unanswered questions that I'm going to go and take now. So now would be a great time to ask questions if you haven't already. And I'm just going to go here and see which will be useful. Maybe I can take out some of these thank yous out of the queue so I can see the questions more clearly. Yeah, so somebody commenting that they registered for the plugin after it came out and still not received it. The GPT plugin, the thing that's actually in the ChatGPT interface is not under our control, I'm afraid. They have been rolling it out gradually, and I don't know how much of that is because they are managing their CPU capacity against interest, or how much of it's because they want to upgrade you to a pro account. I believe at this point they have made them available to everyone with one of these $20 pro accounts. But I don't know to what extent they rolled them out to free accounts. I've got a free account, but I'm different because I've got a developer account. So I've been given access, even though I'm using a free account there. Okay, so if GPT 3.5 uses transformers with self-attention and has a token limit of 4,000, wouldn't its self-attention be the same length per head? Okay, so there's a couple of subtleties for attention, which and what you can put into these things, and you will see this if you use them in anger, that you will get these exceeded attention limit warnings when you start doing sophisticated things. A couple of things to be aware of. One is the attention has to include all of the context. So when you have a chat conversation, the way that it knows what you said before is that every time you ask it a question, everything you have said in that conversation is sent back to the LLM as context. So your question might be, what day is it? But if you've been talking to it for an hour, then you might have an awful lot of context that's built up that is filling that space. So that needs to be managed. And when you are building chat within the Wolfram language, it seemed too detailed for this talk, but we have a symbolic representation of a chat session that allows you to control the context, to be able to drop items that you decide aren't worth keeping, or to keep the length down. And within the chat notebook, we have a notion of a chat block that allows you to say, from this point downwards in the notebook, we're in a new context. So you may be sending the LLM more than you realize because of this context. The prompt engineering is also included in the context. So you don't see that when you use ChatGPT, typically, that there is a whole load of context that says things like, you will not say anything offensive, you will not reveal your inner rules, you will not do this, you will not do that, you will not give medical advice. So when you use ChatGPT, there's usually some sort of 50 or 100 lines of prompt before the word hello that you've just said to it. And the output is also part of the context. And also a token is not necessarily a word. A token can be a subword. So if you've got some multisyllabic word like Superman, that might be 2 or 3 tokens. Or it might be 1, depending on the way that the tokenizations worked. So it's unfortunately all a little bit unpredictable about how much information you can put in before you hit the token limit. And you kind of have to figure that out with a bit of experimentation, and then catch the errors when you get rejected, and know what to do to constrain it if you're exceeding your limit. Okay, let's go down here. So okay, this I will share because I didn't know this, that plugins are only available to be used in the Mac PC interface. So from a desktop browser, if you're accessing from an iPhone, oh no, it's a question, will the plugin be able to work with that? I have to say, I don't know the answer to that. If you use Chrome on your mobile, you can always enable the desktop mode, so it pretends to be on the desktop, in which case it will be available on your phone, but you might end up with really, really small fonts if you do that. So I don't know the answer to that, I'm afraid. Okay, is the documentation page for the plugin on Wolfram? The Wolfram language parts, there is a there is documentation for. That's not public yet, though. So if I just give you a glimpse of it, oh no, so that's a browser. What I want here, I want a Mathematica window. Help. So all of these LLM functions will be fully documented once you once we roll out the version 13.3 of the Wolfram language, and these documentation then will be on the web. It is a very short amount of time away now. I don't have the date at my fingertips, but we're talking days to small number of weeks, not weeks to months at this point. So we're just in kind of final checks on rolling this out. The actual plugin itself is doesn't have any documentation in the ChatGPT interface, and it's also worth mentioning, although I left it out of the details, that the chat notebook and some of the chat functionality is already available to version 11.2 users if you install a Packlet. If you look at Stephen Wolfram's blogs describing this, they all start with a section on how you can install the chat notebook plugin Packlet for Mathematica and how to install the LLM tools. So much of what I've been shown, although it's not built into version 13.2 of Mathematica, can work from there. I doubt if it does from earlier versions, but it might. Yeah, OpenAI have talked about making the plugins available to everyone, so I don't know if that is still their plan. They occasionally pivot on their strategies, but as far as I know, they are still planning to release plugins to everyone. I think they're just dealing with the scaling rollout. How precise are LLMs to generate the expected signatures? So how much can you control what they do? There's two aspects to this. One is the prompt engineering. The more precise you are, the more pedantic your instructions, adding phrases like answer with a single word if that's what you want, and saying do not do this, do not do that. The more you put in precise instructions, the more you can constrain them. There is another detail which I've skimmed over, which is there's a notion of temperature, which is the amount of randomness in the large language model. So typically, as I said, if you don't have randomness, it doesn't feel so human. But when we use the LLM function, and we're treating LLMs as a way of doing functional tasks within the Wolfram language, you kind of want more predictability. So by default, when you use LLM function or LLM example function, the temperature is turned down to 0, so they become more deterministic. And when you use LLM synthesize, the default is to have a temperature of 1, so that they seem more human-like. And you can set any value in between, and if you start going significantly above 1, then they start hallucinating big time. And by the time you're at a temperature of 2, they've broken down into some hallucinatory acid trip and talking gibberish. So you can play around with that to control it. Even with the temperature of 0, they're not entirely deterministic for deep technical evaluation reasons, but are largely predictable, or largely reproducible, I should say, not necessarily predictable. Do you have a sense of error rate for the Wolfram code written by GPT, 10% or less, question mark? It is all down to it's mostly down to the complexity of the code. So if it's something you could write in 3 or 4 lines, I would say that you're getting something that is broadly right 90% of the time and maybe fully right 70 or 80% of the time. So, when I say broadly right, something where you can just spot that there's an incorrect option name, and usually it's syntactically correct, although I did get an example where the brackets didn't match when I was playing with it yesterday, which was a new one on me. Some areas it's better at than others, so it is terrible at anything in the world of entities. It always hallucinates entity names. So these entities are things like, in our world, are things like city or atomic particle. And in our world, if you have an entity of type city, we know what that means. We know where it is in the world. We know about its population, things like that. It makes up entity names that don't exist. It just likes to stick in a word like, it'll just decide to say, what's the population of entity of type habitation? And it does quite poorly on entity-related things. But we're hopeful that this training information that we're providing is going to help that. We are now at the end of our 90 minutes that we have, and I have a lot of unanswered questions that I haven't got to. I'm just trying to see if there's one that is completely different. How ethical is it to use ChatGPT to write scientific papers? That's well, how ethical is it to pass off ChatGPT as your own work, full stop? I think it's a little bit like coding. If you're using it to clean up language or phrase things, I am routinely doing this with my writing at the moment, where I can write what I mean much better than asking it to write the words for me. But once I've written them, it can write my word better than I do, and it's just much faster to get it cleaned up. I think if the essence is from you, I think it's completely ethical. If you're abdicating the content decisions, then I would guess that's just cheating, isn't it, in any walk of life? And perhaps that seems like a good point to stop. So before we wrap, let me ask you, please be patient as we close the webinar, because we end with a quick 3-question, survey. It does help us to know how we're doing with these webinars. So please hang on for an extra 30 seconds and give us some feedback on this and what other webinars you would like to see in this series. But that just leaves it for me to say thank you very much for attending and for sticking around, those of you up to the end of the webinar. Thank you and goodbye.
はい、ありがとうございます。何か、ちょっと待ってくださいね。ですね、いくつか質問をいただいているので、それも合わせてですね、ちょっと補足ということで、今ジョン・マクルーンが話した内容と、被るんですけれども、ちょっと私の口からですね、デモンストレーションを説明というかですね、紹介をいたしますね。でですね、例えばまず最初には、どうしようかな。ですね。ですね。ごめんなさい。これですね。まずチャット GPT、これ画面ですよね。見えてますかね。はい。チャット GPT に入った状態です。で、ウルフラムプラグインを最初の方で紹介していましたけれども、これはここですね。チャット GPT プラス月に$20払わないといけないんですけれども、に登録いただいている方は、プラグインとして、いろんなもの、今もう何百ってあるみたいですけれども、その中からウルフラムのプラグインを選ぶことができます。で、ちょっともう私がもうインストールしたあれがあるの、過去があるので、ここに出てますけれども、そうでない場合はですね、このプラグインストアに行って、ウルフラムと入れればですね、ここに出てきますよね。これをインストールすればいいということです。はい。でですね、例えば、これを実際に、もう一度お見せしますと、これ実際にこう使ってです、チェック入れて、日本語でやってみましょう。例えば何ですかね。例えばですね、10万、1万でいいや。1万までの素数の和とかですね。やるとですね、これ無料版のチャット GPT でやるとですね、さっき足し算の例で出ていましたけれども、こういう、ちょっと算数的な、数学的な問題になると、かなり適当な嘘をシャーシャーと、言ってきます。さも本当にこうだというような雰囲気で言ってくるのは怖いところなんですが、いてね。で、ここをクリックすると、中で何をやっていたかというのが出ます。プライムパイ1万、そうですね、1万、そうですね、プライムパイは、そう、与えられた整数以下の、素数の数を答える関数なので、これで大丈夫ですね。そこまでのレンジのリストを作って、で、そのプライム、1番目からその番号までのプライムを、素数を全部トータルするという形ですね。で、これをですね、実際にちょっと今、やってみると、ちょっと、マスマティカでやってみると、確かにこの答えですね。はい。で、例えばですね、今いただいた質問の中に、ウ 例えば縦軸をログプロットでやってとかって言えばやってくれるんですかという質問をいただいたんですけれども、それもですね、例えばやってみましょうか。サイン、これ、例えばですよ。例えば今ちょっとこれもでっち上げますけれども、コサイン 2x かける e の、どうしましょうか。マイナス x 次乗割る100とかってしましょうか。x はマイナス10から10まで書いて、みたいなことをしてですね、これまたウルフラムプラグインを使ってますよね。で、これ出ます。そうですね。はい。はい、こんな感じですね。で、ここで、じゃあ今度は縦軸を、ログにして、言えば、またプラグインを使ってですね、書いてくれます。まあ、こんな感じですかね。はい。まあ、1、ほとんど1以下なので、まあ、ほとんど負ですね。という感じになっています。で、これがまあ一つ、そのウルフラムプラグインをチャット GPT で使って、で、返ってくる答えの正確性を高めるという話ですよね。でですね、あと、ジョンが話していたものの中に、ですね、チャット GPT プラグインディプロイというのがあったんですけれども、これはですね、一瞬何のことかちょっとパッとこうよくわからないところがあったので、私もこれ実験してみたんですけれど、例えばですね、これはこれも今、ちょっと私が勝手にでっち上げたタスクです。計算タスクですね。で、1万じゃなくて、これは10万ですね。10万までの整数の約数の数のリスト。例えば、5は素数なので、2つしか約数ないですけど、10だったら、1、2、5、10の4つ約数があるわけですよね。で、1から10万まで、その各整数の約数の数をリストすると。すると、その約数の数分布が、見えますよね。で、これはヒストグラムです。で、ほとんどはこの辺に0から40ぐらいまでなんですけれども、約数がやったら多いやつはですね、120ぐらいになるんですね。で、それはそれとして、で、80、例えばですよ、適当に選んだ数が、80以上の約数を持ったら、非常にこれ確率的に低いので、大当たり的なものだとして、すごい約数いっぱいある数だよね、というふうに教えてくれるような、タスクというのを今勝手にこれでっち上げてます。で、そのためにはですね、まずこの ChatGPT プラグインキットっていうのをまずインストールしなきゃいけないんですけれども、これは13.3、バージョン13.3であれば、誰でもできます。で、ChatGPT プラグインキット、パクレットインストールして、このパッケージをロードして、でですね、チャット GPT プラグインクラウドデプロイ。これクラウドを今ちょっと使うので、こういう関数を使うんですけれども、で、number of divisors と約数の数っていう、名前をつけてですね、で、プロンプトとしてですね、プロンプトとして、例えばですよ、もし、 約数の数が80よりでかければ、すごいねと言ってほしい。褒めてほしい。すごいねとかですね。いうふうにして、ちょっとこうするとですね、明らかにこれはなんていうか、ここでカスタムした、内容ですよね。で、こういうプロンプトを用意しておいて、でですね、実際の計算作業として、えんあの、ディバイザーズ、約数の数の長さを調べるという計算を、指定しておきます。で、これは API ファンクションの中に入れておけば、ですね。で、もう一個かな。もう一個かな。これで閉じますよね。はい。ちょっと待ってくださいね。合ってるはずなんだけどな。さっきやったらうまくいったんですけどね。これ、もう一回やってみましょうか。あれダメだな。ですね。うまくいきましたね。で、そうすると、ここにですね、URL が出てきます。この下の出力のところに。で、ここにですね、私のこの、アカウント名、コージ M というのにくっついたアセッツウルフラムクラウド .com というのがあるんですね。で、これ今もしかして、よかった。ちゃんと共有されてますよね。でですね、で、これを持って、またですね、チャット GPT に行くんですね。チャット GPT の画面は、さっきのやつこれですね。これですね。で、例えばですよ。で、これでですね、ちょっとニューチャットにしましょうか。で、Number of Devices、私さっき実験したので、もうすでにここにあるんですけれども、ちょっとあくまで一回これやめてですね、もう一回選び直します。で、プラグインストアに行って、で、この右下にですね、ちっちゃく字が並んでるんですが、ここに Develop Your Own Plugin というのがあります。で、ここにさっき出てきた、マセマティカで出てきた URL を入れます。cogmassets.wolframcloud.com ですよね。で、ここで、find manifest file と、サブミットして、で、はいはいと、進みます。はいはいはいと。で、そうするとこのカスタム、自分で作ったプラグインが、チャット GPT に読み込まれてインストールされるんですね。そうしたところで、例えばですよ、例えば、600の約数の数は、みたいなことを聞くと、600なんていうお行儀のいい数はですね、あんまり約数、の数がそんな80もあるわけないわけですよね。24しかないですよね。なので、普通に24と、さっき入れた、インストールした、プラグインを使って、答えが返ってきます。で、実際にですね、じゃあ、いっぱい80以上の約数があるような数を入れてみると、例えばですね、さっき実行した中にですね、リストをわざわざ作ったので、それを見るとですね、例えば91080の800だと、とかっていうふうに聞くとですね、これ96個の、約数があるんですけれども、またこの Number of Devisors というプラグインに投げて、 こういうふうに返ってくるわけですね。で、さっき英語でプロンプト書きましたけれども、当然、チャット GPT は、翻訳もできるので、その辺がこう直って出てくるという形ですね。で、これがさっきイギリスの所得税の、控除の話でジョンが話していた、ものになります。こういうふうなことができるよという例ですね。で、またですね、ちょっとお待ちくださいね。で、もう一個で、あと、チャットエネイブルドノートブックというのが、これかな。これですね。これどうやったかというとですね、マセマティカ、これマセマティカです。で、マセマティカでファイル新規作成の中に、チャットエネイブルドノートブックというのが13.3、あるいは13.2でパクレットインストールすれば、出てくるようになってます。これ特に、なんていうんですかね、追加の、なんていうか、費用がかかるようなものではなくて、13.3ではもう自動で入ってます。で、ただしですね、ごめんなさい、オープン AI にウルフラム、ウルフラム言語から、つなげるときにはですね、実は、ちょっと待って、その前にちょっといろんなことが混乱気味でご申し訳ないんですけれども、これかな。このウルフラム製品の中でチャットノートブックを使う方法というのが、これページがあります。これ、ウルフラムオープン AI キーとかって検索すると出てくるんですけれども、これをやらないとですね、接続されません。ウルフラム言語からさっきお見せしたようなプラグインもそうですし、今度お見せするチャットエネーブルドノートブックもそうですけれども、これをやらないとですね、できないです。で、これは別にチャット GPT プラスでなくてもいいはずなので、これ自体はですね、どなたでもできるはずです。で、チャットエネーブルドのノートブックの方に戻るとですね、これですね。さっき、ジョンがビデオで見せていたのはこんなやつですよね。最初の500個の素数の間の差をプロットしてくれと。そうすると、これも大きくしましょうか。こんな感じですね。で、これ出てきたやつをですね、これ選ぶ、カーソルを合わせるだけで、なんか出てきます。で、再生ボタンみたいなやつがあるので、これをクリックすると下で、今度実行できます。で、これまたこうやって、なんか順番が違ってますね。まあいいや。で、こんな感じですよね。で、これがまさに、素数の差のプロットです。で、もう一個チャットインプットっていうのをやって、これを線で結んで、なんてやれば、今度は全部まとまって出てきましたね。で、こんな風になると。これがビデオの中でお見せしていた、例ですね。で、それからですね、ここでもですね、さっき、ちょっと、チャット GPT 上でお見せした、縦軸対数にするというやつもできます。サイン x 足すコサイン 2x の e のマイナス xg 乗割る100を、マイナス10から10まで書いて、ですよね。で、これが、普通のやつです。で、ここで、また上でチャットインプットの縦軸をログにしてと。 で、そうすると、こんな感じというところですね。はい。これの場合は、こっちの方がお行儀がいいですね。ちゃんと、ログスケールになってますね、これね。というところですね。なんか変な、さっきの結果が変なのかな、なんか変なちょっと気がしますが、ちょっと目をつぶりましょう。はい。で、あとですね、最後質疑応答の中でも、ちょっとあったんですけれども、あの、こういった機能をウルフラム言語コードを書くのに、使えるわけですね。コード生成という機能としコード生成機能として、なんていうかな、活用できるわけです。なんですけれども、最後の質疑、ウェビナーの中の最後の質疑にもありましたけれど、実はですね、エラーが起こることもあります。でですね、例えば、これはですね、うまくいくかな。うまくいかないですよね。で、これがさっき言ってたえーコンプレクシティだと、コードのコンプレクシティによるという答えをしていましたけれども、それに相当していますね。で、これ例えばですね、これ多分、この括弧が二重になってるのがいけなくて、これでうまくいくはずじゃないかな。いきますね。こんな感じですね。で、こういうふうに、してですね、ここに実は、これちょっと見にくいんですが、このセルの、右の上、セルのこの括弧の右上のところにですね、あの、もうなんか本当に見えにくいんですが、Send to LLM というボタンがあります。カーソルを合わせると Send to LLM と出てくるんですが、これをやるとですね、これを押すと、教えることになるんですね。LLM に対して。今の場合には LLM として使われているのは ChatGPT しか今はないんですけれども、えーこれが送られて、あちらでですね、すいませんでしたというお詫びが返ってきますと。で、これが正しいコードですね。でも、これでお試しくださいっていうんで、お試ししてますと、はい、出ましたという形ですね。はい。そんなところですかね。ちょっと補足事項として、私がお見せしたかったのはそんなところです。はい。よろしいでしょうか。ちょっとですね、いろんななんていうか、キーワードが飛び交って、ウルフラム側から呼ぶのか、チャット GPT 側から呼ぶのかとかですね、ちょっと混乱の元になりそうなものがたくさんあるんですけれども、今回のビデオは後ではまた公開しますので、字幕付きのやつを公開しますので、そちらも参考にしていただければと思います。はい。基本的には以上になります。で、Q&A の時間を、少々10分、15分程度取りたいと思うんですけれども、何かございましたら Q&A ボタンの方から、入れてください。チャットというボタンが右下かなにあると思うんですけれども、それをクリックすると、一番上に、チャッツと、あと Q&A っていうのがありますので、そこで Q&A ですね。から入れる Q&A をクリックして、さらに一番下にこの入力のスロットがあります。はい。ちょっとそれをお待ちする間にですね、またポール、をしてみたいと思うんですけれども、あのマニュアル上半、これもいつも伺っている質問なので、特に親身があるわけではないんですけれども、これもお答えいただければと思います。で、あとですね、このウェビナー出るときに、サーベイとして、2問くらいのサーベイと自由入力の欄がある、アンケートが出ますので、画面が出ると思いますので、そちらへのご協力もお願いいたします。 はい。先ほどのね、最初の、ポールでも、一旗あげたいとお答えいただいた方が何人かいらっしゃいましたけれども、そうですよね。一旗あげるには早い方がいいと思いますので、もうこういうのはね、時間との競争なので、私も一旗あげたくてうずうずしてますが、なんかあれば、内緒でやりましょう。はい。えーで、こんなところでよろしいですかね。あと5秒でもう閉めちゃいますね。質問よろしいですかね。私の、限られた知識ではありますけれども、の範囲内でお答えできるものはお答えしたいと思います。ChatGPT の中で何をやってるかっていうのは非常に面白い問題で、スティーブン・ウルフラムも、ブログの中でね、何を書いや、ChatGPT がやってるかみたいなことを解説していますけれども、解説あれでいいんですけれども、それでもなんであんなにうまくいくかっていうのは、今のところなんていうか、大きな謎みたいですよね。はい。ですね、ちょっと待ってくださいね。ちょっと待ってくださいね。ちょっと待ってくださいね。今何が共有されているこれですね。はい。質問いただいたのがこれですね。チャットノートブックやレーレンファンクションを Azure OpenAI サービスでも使えるように貸します。できると思いますけどね。できると思いますね。これは、私自身試していないし、そういう話は聞いてないですけど、ただ、技術的になんかこれを妨げるものはないと思いますので、できると思いますが、できないとしたらですね、ちょっと別途、お問い合わせいただければ、開発部隊に聞いてみます。これはわかんないですけど、できるんじゃないですかね。はい。すいません、なんか適当な答えになっちゃいますが、ChatGPT 日本語対応のオープン AI がどうですね。通常の処理をしているには、柔軟性に大きく欠けている気がしますし、日本語の LLM を一から組み立てると、そのトークンとかテンションがその日本語やってる。これはちょっとオープン AI 側の、なんていうか、テクニカルな内容かなという気もしますけれども、いや、結構ですね、やってると思いますよ。一から組み立てているという意味、ただ日本語の LLM を一から組み立てているっていうよりかは、作った LLM を日本語にもただ当てはめているというのが多分本当のところじゃないかと思いますけれども、トークンとかアテンション概念をそのまま日本語に当てはめるかどうかっていうのは多分これは当てはまりますね。これは当てはまると思いますね。言語である以上、トークン化する、トークナイゼーションするとかですね、アテンションの、定量的な評価とかですね。これは、当てはまると思います。はい。日本でも独自の LLM を作る。これはどうなんでしょうね。ちょっと、ウルフラム社としては、なんとも言えませんね。私も新聞で見る、記事以上の情報はないですけれども、なんかね、政府が、本腰入れて、安全保障上もやっぱり、外には頼りたくないからやろうな、みたいな話はありますけれども、ちょっとすいません。ここまでは私もわからないですね。ええ。はい、それからですね、はい、ChatGPT のアップグレード版を購入しないとプラグインはできないのですかという質問ですが、はい、そうです。ChatGPT プラスというですね、月に$20払わないといけない、ものを購入しないというか$20払わないと、ウルフラムプラグインだけでなくて、今何十か何百かあるプラグインは使えないですね。こればっかりはちょっとごめんなさい、仕方がないですね。はい。あとですね、こういうのは面白い話ですね。こういうのはね。計算結果から何がわかるかを尋ねることは、尋ねることは多分できるし、もちろん尋ねることはできるし、チャット GPT は何か言ってくるとは思うんですけれども、 それが本当かどうかっていうのはですね、怪しいですね。で、そこに関してウルフラムプラグインがじゃあ役に立つかっていうと、それも怪しいですよね。何がわかるかを尋ねるっていうのは、はっきり言って今のいわゆる AI と呼ばれるものじゃ無理ですよね。人間じゃないと、意味のあるその理由とか、その背後のロジックとかっていうのは、所詮 AI は AI なので、そこは無理かなと。どの程度のものかにもよりますけれども、無理じゃないかなという気がしますね。はい。この辺は、奥が深い話なので、ちょっと面白いですよね。13.3はいつ出ますか？13.3もう出てます。はい。もう出てますので、アップグレードできる権利をお持ちの方は、もう、どんどんアップグレードしちゃってください。そうでない方は、代理店等にですね、別途、問い合わせいただければ、今キャンペーンとかあるのかな？わかんないです。ごめんなさい。ちょっと今失念してますけれども、あればそういう情報も提供されるかと思います。でですね、資料の解除方法。これ、資料っていうのは今日のですかね。今日の今のチャット画面の右上のピンクのバナーがあると思います。資料をここからダウンロードするというところに、あります。ここに今日はジョン・マクルーンがですね、ウェビナー本体で使った、ノートブックが置いてあります。それから、今日のビデオは、字幕付きのビデオはまた後日ですね、YouTube に載せます。YouTube の、ウルフラムジャパンチャンネルというのがありますので、そちらをですね、楽しみにしていただければと思います。ウルフラムジャパンはですね、ここでご存知ない方もいらっしゃるかもしれないので、再度ですね、宣伝しておきたいと思うんですけれども、これですね、ウルフラムジャパンというチャンネルがあります。はい。ここにいろいろと、小ネタであるとか、過去のウェビナーの動画とかですね、載せてありますので、こちらもぜひご活用ください。インターンのですね、大学院生が作ってくれている、本当に初歩の、最初のコードの仕方、コーディングの仕方、マシマティカの使い方みたいな動画もあります。はい。ので、ぜひご活用ください。で、ついでにですね、ちょっとこのブラウザに行ったところでお見せしたいんですが、これですね、これもさっきのウェビナー本体の中でちょっと話がありましたけれども、ウルフラムプロンプトレポジトリというページがあって、で、ここにですね、チャット GPT に投げるときの、その、プロンプトエンジニアリングの手助けをするような、関数が出ています。はい。今大した、こんなこと言っちゃいけないんですが、あんまりなんかこう、面白いのはないかなっていう、面白いっていう、何をもって面白いかというかにもよるんですけれども、ペルソナの、さっきありましたよね。5歳児に対してブラックホールを説明するとか、そういうような例とかをどうやってやるのか、みたいなのが出てますね。これは、海賊が喋るような、言葉で、会話するにはっていう。ここに LLM プロンプトという関数が出ていますね。はい。そんな感じですかね。そうですね。はい。もうちょっと時間もあれなので、すいません。ご都合のある方は、何か用のある方は、逐次退席なさって結構ですので、アンケートだけご協力ください。チャット GPT 以外の生成 AI との連携が今後あるんです。これはですね、一応ある予定にはなってます。バートであるとか、なんちゃらであるとかって、いろいろありますよね。一応そういう予定にはなってると聞いています。ただ現状はチャット GPT だけですね。はい。 ええええええええ。はいはいはいはいはい。はい。私が使ったというかお見せした、動画ですね、デモの、なんていうんですかね、ノートブック、資料も、ダウンロードできないかというご依頼ですけれども、そうですね、はい。そうですね。あと動画ですね。動画はこれ多分今これ全部録画されてしまっているので、これも合わせて YouTube に載っければいいかなと思いますね。で、資料ですね。私がちょいちょいこうノートブックを使ってお見せした資料も、そしたらYouTube じゃない、その動画が用意できた段階で、その皆さん参加された方にご案内するメールで送ると思うんですが、その中にダウンロードリンクも付けたいと思います。これちょっと忘れないようにしないといけないですね。忘れないように、ここにメモっておきます。資料へのダウンロードリンクも送付と。はい。はい。はい。それとですね、へへ。所持データをウェブから探しめチャット GPT に依頼し、そのデータを忘れて、ごめんなさい。これ今、すあの、共有がされてなかったですね。はいはい、これです。はい。自分の必要とするデータをウェブから探すようにチャット GPT に依頼し、そのデータをマスマティカに読み込んで活用する。どうなんでしょうかね。どうなんでしょうかね。そこまでやったことがないですけれども、こういうのっていうのは、なんか、なんか人間のこう奥深い欲を垣間見るようで面白いですが、再現がないですよね。ぜひ、お試しください。試して、皆さんのご専門の分野であれば、その出てきたものが正しいか正しくないかっていう判断も、できると思いますので、そこでどうだったかっていうのをぜひですね、伺いたいですね。はい。分野による違いとかもあるかもしれませんし、ちょっとその辺私も個人的に興味がありますね。ええ。はい。ですね、あとこれかな。ウルフラムが独自の専門性のある LLM を作る可能性はありますか？チャット GPT ウルフラム間の呼び出し回数を読みこの1番はですね、どうなんですかね。私の腹積もりというよりは、これ多分社長の腹積もり次第なので、話を私自身はそこまで聞いてないです。今のところは。ただ、スティーブン・ウルフラムが何か言えばですね、そっちに動くので、当然といえば当然ですが、そればっかりはなんともわからないですね。はい、ちょっとわからないです。なんか聞こえてきたらですね、次回こういった機会の時に、ちらっと紹介したいかなという気はします。はい。LLM でも作るのって大変なんでね、お金もかかるし、ものすごいリソース食うので、どうなのかなって気はしますけどね。で、これ、一般論として、こういう機械学習なり AI って一度出てしまうと、コモディティ化するんじゃないかっていう議論がありますよね。なので、そこに後発として入っていくメリットはどれぐらいあるのかとか、そこは私が判断するものではないので、ちょっとすいません、わからないです。で、チャット GPT ウルフラム間、あるいは逆方向の呼び出し化する。これはですね、多分ないと思いますね。ないです。多分ないです。すいません。間違ってたらごめんなさい。ただないと思います。私の知る限りないです。で、むしろ制限になるのは、ジョンのビデオの中にもありましたけれども、トークンの数ですね。チャット GPT に投げられるトークンの数は制限がかかっているので、それですよね。そっちの方が大きいかなと思います。はい。ね、なんか2万トークンとかっていう話がビデオの中にもありましたけども、そっちが主たる制限じゃないかなと思いますね。はい。はい。 想定されている基本的な使い方下記のようなものですが、標準的なウルフラム、プラグインを ChatGPT に入れて使い、許せません、検査的な。まあ、そうですね。そうですね。そうとも言えるし、まあ、これはもう何と言いますか、まあ、個人の、まあ、好き嫌いの領域に近いものがあるかなと思いますね。ノートブックで使うメリットは、ノートブックなので、なんていうんですかね、元に戻って実行しても、その矛盾が起きないっていうようなところですね。で、チャット GPT まあ、ああいうコマンドベースで対話型のやつっていうのは、まあ、基本的に上に戻って、そこでまたね、操作をちょっと編集してみたいなことがやりにくいので、まあ、ノートブックっていうのはそこがメリットにはなってるわけですよね。まあ、あとはそうだな、専門的な計算、そうですね。まあ、専門性にもよりますけれども、現状ではですよ、現状ではチャット GPT にウルフラムプラグインをつけてインストールして使う場合にはですね、ウルフラムアルファにつながるんですね。でウルフラム言語という意味では、まあ、同じなんですが、ウルフラムアルファなので、本当に専門的な計算をカスタムで自分の計算をしたいっていう場合には、ちょっとアルファはそこまでの自由度はないです。なので、おっしゃる通り、ノートブックで自分でコードを書いて、それとチャット GPT なり、なんか生成 AI を接続させてやるというのが、まあ、健全な使い方だと思いますね。そうですね。その好き嫌いというより、そういう見方の方が正しいですね。はい。これなんか、先ほどのご質問に関連する情報ですね。チャット GPT の結果をマシマティカで使う方法が紹介されています。だそうです。ありがとうございます。コミュニティですね。ウルフラムコミュニティ、になんか投稿されているようです。はい。といったところでしょうか。これ大体お答えしたのかな。そんなところですかね。はい、はい。えー、そうですね。はい、ありがとうございます。いろいろと、あの、刺激になりますよね。こういうことを考えると。まあ、やっぱりチャット GPT の、まあ、ビデオの中にもありましたけども、良さっていうのは、その言語に関する処理については、やっぱりちょっと抜きん出ている。その曖昧さとか、完全に構造化されていないものでも理解できるように見えるところですよね。で、まあ、そこにウルフラムのその論理的な、ロジカルな思考っていうか計算が組み合わされば、まあ、非常に信頼性の高い、なんていうかな、アプリというか、システムを作ることができるんではないかという希望が持てる内容だったかなと思います。はい。ぜひですね、一旗皆様と挙げられるようにですね、頑張ってまいりたいと思いますので、そうですね、本当ですよね。本当ね、一旗挙げられたら楽しいでしょうね。ちょっとなんかありますが、ちょっと、これはすみません。ちょっと個別に後でお答えします。はい、どうもありがとうございました。長い間。こんな感じで12時にもう近いので、そろそろこれも締めたいと思います。よろしいでしょうか。はい。では皆様お疲れ様です。はい、失礼します。